hello everyone. Today we're going to do chapter 4 of Learning Basic, aka Teach Yourself Basic, for the Texas Instruments TI-99 for a home computer. Without further ado, let's just get it loaded up. So I've got the program saved in disk 2 in this emulator, Classic 99, and chapter 4. Let's load it up. It'll take a second for it to load, and I honestly don't remember what's in chapter 4. When I was a kid, I had this 10-part Teach Yourself Basic, aka Learning Basic, on cassette tape. I used to do them all the time, but I don't remember what order the chapters were in. Okay, so let's run the program, and let's see what we get. I don't really remember what's on chapter 4. Okay. I love the graphics on the TI-99 4A. Learning Basic, Chapter 4. Programming. Okay, let's do some real programming. It might be good to start by programming the computer to play a game. Let's try the game called NIM. First try playing the game, and then I'll show you how to program it. Press enter. NIM. There are 21 stones in a row. You can take 1, 2, or 3 stones in your move. Then I can take 1, 2, or 3 stones in my move. We alternate moves. The player who takes the last stone loses. Okay, you go first. Okay, so this is an interesting challenge here. 21 stones. So let's think this through for just a minute. So if I take 3 and the program takes 2, let's say what takes the last stone loses. Okay, so if I take 3 and the computer takes 2, that's 5 done. All right. It must boil down to the last couple moves. So let's just take 3 to start. Okay. I take 1. Okay. How many do you take? Let's take 3 again. I take 1. How many do you take? 3 again. The first few moves probably don't matter. Maybe they do. I don't know. I'm not reasoning through the... Okay, 3. Take 1. Want to play again? Yes. Okay. Maybe this is one of these games where you can't win no matter what. The computer always wins. I'm not sure. Okay, let's try 2 this time. So I did even, he did even. I do even. Computer does even. I do even. Or maybe whoever goes first wins. Let's see. Let's say I do 3. 1. Let's see here. Is it possible for me to win at all? Okay, no, that's okay. Now let's see how to program this game. Okay, I pretty much suck at that game. We have to know what to program. So first we must understand the strategy of the game. For simplicity, let's use only 9 stones instead of 21. The object of the game is to get your opponent to take the last stone. Oh, okay. If we can get him to take this stone, we can get him to take the last one. Makes sense. Now we can get him to take number 5 by having him go first. Think about this. Right, okay. So whoever goes first loses, basically. trick game. I hate those kinds of games. Here's our strategy. Our opponent goes it's like tic-tac-toe. It's not fair. Here's our strategy. Our opponent goes first. If he takes 1 stone, we take 3, forcing him to take number 5. If he takes 2, we take 2. If he takes 3, we take 1. Right. Okay, let's start the program. 10, call clear. That clears the screen. 10 is the line number. Every statement should have a line number. Press enter. It is usual to have 10 as the first line of the program, and 20 as the second line, and so on. That way you can insert line numbers if you need to, if you leave something out. Statement 10 erases the screen. Yes, it does. Of course, every version of BASIC has its own version of this, and in TI BASIC it was call clear. Sometimes it's just CLS and other versions of BASIC. Print nim. That just prints the name of the game. Print allows us to print things on the screen. Text inside quote marks, prints on the screen. They don't call them quote marks anymore. Press enter. Colon means skip a line. 2 colons means skip 2 lines after printing nim. Press enter. Must be nim for Nimrod if you can get someone to go first. N equals 9 just means take a variable called n and let it be the number 9. N is the number of stones. Print there are n stones left. Here is a more complicated print statement. Semicolons separate things to be printed. So statement 40 prints there are, and then prints what n equals, and then stones left. Press enter. If we were to run the program now, we would get nim, there are 9 stones left. Press enter. Okay, 50 input. Take 1, 2, or 3 stones, and then colon D. This is an input statement that allows you to enter data from the keyboard. Right after the word input, you can have text in quotes. This is printed on the screen. This statement says the number of stones that you enter from the keyboard will be called D. You need not put printed material in the statement. If you do, a colon is needed. Print I take 4 minus D stones. So here's why this game isn't totally fair. Another print statement first. First quote I take is printed, then the quantity 4 minus D is calculated. The value of 4 minus D is printed. Finally, the word stones is printed. This is our game strategy. The computer will take 4 minus the number that the player takes. N equals n minus 4. So it just redefines the number of stones that are left. Statement 70 does not seem to make sense. How can n be equal to n minus 4? Because we're not doing an equation, we are redefining the value of n. In computing, equal sign means something different than in arithmetic. It means replace. So n equals n minus 4 means subtract 4 from n and call the answer n. The total number of stones remaining is n. Press enter. 80. If n is greater than 1, then 40. How is the computer to know when it has 1? If n equals 1, 1 stone left, then the computer has 1. This is an if statement. It says if n is greater than 1, then go back to statement number 40. Of course, in logic, that's called a conditional if then. 90, print. There is 1 stone left. I win again. However, if the computer has 1, n equals 1, then the computer will tell you so. Statement 100 ends our program. It says that the program is at the end. This is our game program. When you are finished studying it, press enter. Okay, so let's just run through the entire program for completion's sake. 10 clears the screen. 20 prints the name of the game, NIM. 30 is the number of stones. We're going to set that equal to 9. 40 prints, there are n, or 9 stones left. 50 inputs a variable. Prints take 1, 2, or 3 stones, and then defines the answer as D, whatever the user inputs from the keyboard. 60 prints I take 4 minus D stones. 70 redefines the number of stones left, n equals n minus 4. And then if n is greater than 1, then 40 just loops back to line 40. And then we just rinse and repeat until we get down to the last stone. Then on line 90, print there is 1 stone left. I win again. 100 ends the program. This ends chapter 4. The game that we programmed is stored on the computer starting at line number 1260. If you want to try it, enter run 1260. And let's do it again. Just for fun. So it doesn't seem like there's any way for us to win this game. So that's why it's called NIM. I suppose this stands for Nimrod. You're a Nimrod if you go first. It'll take a second to load the program. So NIM, there are 9 stones left. Take 1, 2, or 3 stones. We'll take 1. And then what's going to happen, of course, is now that we've learned how the program works, the computer's going to take 4 minus 1 and choose 3 stones. I take 3 stones. There are 5 stones left. Take 1, 2, or 3 stones. Let's take 2. And then the computer will take 2. There's 1 stone left. I win again. What do you do? Let's run the tutorial one more time so we can do the full game with whatever it was 21 stones or however many there were. And then we'll break the program. We're not going to do the entire tutorial again. And then we'll list the program, take a look at the entire program for this chapter of Learning Basic. And then we will call this a very brief stream of Chapter 4 of Learning Basic. Take a second for it to load everything into memory. See someone's viewing. Hello, whoever you are. Thanks for watching. The TI-99 4 is so pretty. I love the color scheme. Of course, this is just an emulator. The original colors were slightly different on a CRT monitor. Learning Basic, Chapter 4. Programming. Dun, 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 dun. Okay, let's do some real programming. It might be good to start by programming the computer to play a game. Let's try the game called NIM. First try playing the game, then I'll show you how to program it. Okay, so there are 21 stones. Okay, you go first. So I'm the Nimrod who goes first. And I think that the same rules apply, although the tutorial wasn't totally clear on this. So if I take 3, 4 minus 3 is 1. The computer should take 1. I take 1. Yep, okay. How many do you take? Let's try, if I take 2, does the computer take 2? Yep. If I take 1, computer should take 3. Yep. Rinse, repeat. I'm the Nimrod. It's impossible to win this game. I take 3. Computer takes 1. 4 minus whatever I take. And the computer wins because I'm the Nimrod who went first. Okay, do you want to play again? No, we get the general principle now. That's okay. Okay, I'm going to go ahead and break the program. And let's clear the screen. And we're going to list out the program here. This is, again, not the program for the game. This is the program for the entire Chapter 4 of Learning Basic, just for completion's sake. See if anything jumps out at us here. These tutorials are pretty complicated, actually. I think this one was quite complicated with erasing certain lines, and this was a more complicated chapter than we've seen in previous chapters in terms of what it's doing on the screen. Subroutines. I used to love taking a pad of paper to school, maybe when I was in elementary school and into junior high, and maybe even a little bit into high school, and I would sit and write programs in BASIC just to amuse myself. Various simple games and things. I think it's a challenge to write on paper. It's good practice, actually. I think programmers should do that more. There we go. There's lots of subroutines, variables. I think that was the thing that was so annoying about BASIC, rather than having, functions that can be called at any time, because the line numbers are sequential. If you wanted to, branch it all, you'd have to go to a subroutine, do that subroutine, then return back to the place in the program. It was a very different kind of programming strategy. It's not hard to adapt to if you're used to modern programming, but it was challenging at the time, because you have to put your subroutines arbitrary. If you're writing a program from scratch, you just have to put arbitrarily high line numbers to start a new subroutine, so it's just out of the way of the main program, so to speak. All right, well, that was Learning Basic Chapter 4 for the Texas Instruments TI-99 4A. And as I said in the first 3 parts, this is a 10-part series. This was originally a 10-part originally it was on cassette tapes. It was a 10-part tutorial on learning basic. The cassette tapes were called Teach Yourself Basic, but the program seemed to be titled Learning Basic. And I was fond memories of these programs from when I was a kid. It taught me a lot. I was a really little kid when I learned a lot of these fundamental programming concepts, and served me well later in life. But I haven't looked at them in years, so I'm having fun going through these. If you're watching this on YouTube, go back and check out chapters 1, 2, and 3 if you haven't seen them already, and stay tuned in subsequent days and weeks for chapters 5 through 10 coming up when I get that far, sometime in the next days or weeks. Thank you for tuning in. If you're watching this live on Twitch, I'll be back with some gameplay soon. Probably World of Warcraft, maybe some sort of retro game. I'm not sure exactly yet. Give me just a few minutes to reconfigure my system, and I'll be back in a bit. Take care now.